saying 1, 3, 5, 7, 9, and then 2, 4, 6, 8, 10. It's 1, 2, 3, 4, 5, 6, 7, 8, 10.
Well, we're going to find out in a minute, aren't we? Or you're going to find out in a minute. I'll watch you and see if the light bulb goes off. You're like, oh yeah, now I know what it is. All right, so first thing we're going to do, and this is all from scratch. I'm gonna create a node class first. A little bit different. No signal. I was working a minute ago. When I looked at it. Should have already. Did I disconnect? I might have disconnected because I was scooting around. Oh, okay, I gotta be careful. I gotta get that longer cord. I guess I don't have to buy one. No, I just need to go ask. I don't. I can't blame the college since they don't know it's a problem. All right, so here's one. I'm gonna create a very. I mean, I'm not trying to be fancy here, so I'll tell you what. No, I'm gonna do this on purpose. I'm gonna say I need to change this to be a template, but I'm not gonna do that because I'm gonna make you do that. So this is purposely non-templated, but it will need to be a template for the homework assignment, which I haven't written up yet, but I'll do that here in a minute, or by the end of the day. All right, so we have a node class that has two member variables, a data field, a data member variable, sorry, and because I'm thinking about structures, and a next link. A default constructor. There's that good old null pointer. And then a fully parameterized constructor. Oh. And I like this implementation because it uses the famous this keyword. But again, no, that's not supposed to be next. That's not a circular reference. That's null pointer. Sorry, I was thinking about. I didn't have to write that. I could have just said data equals data, and next equals null pointer. But first of all, that looks very weird. But it works, right? Because this data is a member variable, and this is a. I could have called it something else, but I like data, And so, and then I could have called it any kind of item, value, blah. But I think you do a lot of times. You see this in code on purpose so that you can use this to differentiate, right? And so all this is saying is that this data belongs to the current this object. That's so hard to explain. I mean, I know exactly what it means. I've dealt with this in like 5 different languages. But when still after years and years of using it, it's still hard to explain to people what that means. But it does help. It does help differentiate between things like that, between the member variable and the argument. All right, so that's our node class, and that's all it does. It just allows us to store data in a node. All right, so now we're going to create a linked list class. The way into the linked list, and we're going to do this for all of our linked lists, I think. I'm not sure how much longer we're going to stay on linked lists, but while we do, we're going to always have a head node as the way kind of into the linked list. You're always going to connect through the head. Or I'm sorry, at least have a head node for the connection. So that's the only piece of data that we're going to have, only private data, so that we can go straight to the public section. And in our public section, we will have a default constructor. And again, I'm purposely not making it a templated class, but that will be part of your assignment, is to template it. So I thought I'd leave it out on purpose, just so you can have more practice doing it. I'm just going to leave it like it is. Okay. So we're going to, that will be the only way. We're not going to worry about trying to create a linked list that already has some data in it. That's probably not typical. So we'll only have one constructor. And then we're going to have just one member variable called inserted head. It's going to take a piece of data as its parameter. And then we will instantiate a new node. Or I'm sorry, allocate data for a new node, but it's also kind of doing it like a class. Or instantiate's not wrong. So we create a new node, assign it the piece of data that we want it to hold. Then, if the linked list is empty, if there are no nodes, then the new node becomes the head. I'm sorry, the head gets the new nodes. The head becomes the new node, I guess we'll say. Otherwise, point to that node from the head. Okay, so the new node is going to point at the head to link it, and then oops, sorry. Oh, caps lock. That reminds me. All right. I knew there was a reason why it was saying that was an error. I knew I had an extra curly brace someplace. All right, so this is how we insert into a linked list where we're always inserting at the head. So at the start is the newest element of a list is always at the start, and you'll see that when we write one more function. So then we're going to write we need to be able to display what we're looking at, so we're going to create a print function. Check to make sure that the list is not empty. If it is, then we simply say list is empty and return. Now that brings up something else you don't see very often in void functions, is a return. Okay, this is a kind of another thing that when I was in school, I would have gotten an F and asked to redo it if I'd have put a return into a void function. Okay. because that's you don't want to go any farther. You want to stop. Okay. We could have put it in an, but you could also put it like in an else. Mm-hmm. Yeah, well, and that's right. And then, again, I would have gotten an F on any paper that I put a break into a loop. Because again, like with functions, my education was loops have one entry and one exit. You go into a loop at the top, you go out of a loop at the bottom.
There's so many applications where having break is.
But now, and I see this all the time. It drives me crazy, but I've quit fighting against it. While true loops, essentially an infinite loop that waits for a specific condition to occur to stop. I see it all the time.
I had in my
Uh-huh.
I had a if not head instead of not equal to or whatever.
Mm-hmm.
Which actually the reason I did that is because Visual Studio yelled at me if I tried to put if whatever does not equal. And I have a while 10 instead of while 10 equals something.
Well, yeah, that's all right. That kind of stuff is like the difference between programming 101 and being a little more experienced. Because you can, if you have a single variable that is a Boolean value, then you don't have to do it if it's equal to this or that. You can just use that variable. But yeah, so like when I'm teaching computer science 1, I'll see students the first time we do loops. So this always happens. This happens a lot in my online class because obviously they're not reading my material; they're just doing the homework. Especially if they've already had like a Python class. The very first while loop I ask them to do will be a while true. And I'm like, okay, you didn't see that from me because I never write those kind of loops, but it's clearly prevalent other places. And so, like I said, a few years ago, I would have fought back and said, don't ever do that. Now I'm like, I can't fight it. I can't fight it. I have to accept it. But it's harder to debug that. It's nice to be and that's how I teach while loops. It's nice to be able to look at that condition there at the top and say, okay, I can tell you when this loop is going to stop and when it's going to keep running based on what this condition is. And I don't have to go through all the code and look for an if statement that's going to, where there's a break somewhere, or go find the break and then look for the if statement that's obviously inside of to figure that out. But and then if we were trying to formally prove the correctness of a program, if you go into a 4-year school, you'll take a programming languages course where if your instructor is that kind of person, you'll learn these formal validation things that you learn about how to try to prove if a program is correct or not. And that's a whole field of computer science. Anyway, you can't do that with a while true loop. You can't. It just won't work. So that's why a real, true, formal theoretical computer scientist would tell you, not ever use while true.
Sorry, I was in the library and I forgot.
It's all right. You haven't missed much, just everything. Class dismissed.
Sounds about right.
Yeah. No. So to catch you up, I'm going through one particular implementation of a linked list class that I'm going to ask you all for homework to completely modify and change up. So what we have is we have a node class to keep track of data. Then our linked list class where we have a head node, and then all the data is inserted at before the head. So that's why that member function is called insert at head.
Okay. So node is not a structure anymore?
Yeah, I made it a class. And I'm going to say in the homework, if you would like to turn it back into a struct, would be my guess. If you already have it as a structure, you don't want to have to recopy it and put it in there. And you can template structure just like you template classes, so that's fine too. Anyway, all right. Got a what? Oh, really? Oh, all right. I'll alert physical plant. It's just a singly linked list. We're just calling it class linked list. All right. So we have a head node. When we build the list, the head node is assigned null pointer. To insert, we create a new node to store the data. We check to see if the linked list is empty, then the head node is going to be null. So we're just going to assign the new node as the head, and then we're done. Otherwise, we're going to insert the new node at the head, and that's what those two lines of code do right there. And I'm leaving it a little. What I want you to do is I want you to, as part of your education, I want you to draw a diagram. I'm not going to ask you to turn it in. You're responsible. So you'll do it on your own. So that you can map out how nodes are added to the list by watching how the links change based on this code. So you're just going to draw little squares and change the links as things change. I want you to do that on your own because you're going to need to do that for part of what the assignment's going to be. All right, and that's all that does. Then we have a print member function that simply, first of all, it checks to see if the head is null. If the head node is null, then that means the list is empty. So we return, we display empty and return. And to me, that's kind of where we were when you walked in. We were talking about the fact that this is a void function, but it returns. What do we know about void functions? They don't have return values, right? And this one doesn't. It doesn't have a return value, but as Dalton said, it's kind of like a break in a while true loop. That's where I was on the rant about while true loops. About how when I was a student, that's the automatic F. And you got an F, and then you got the poets versus programmers lecture, where we used to get this after a test. The teacher would go up and put a line, and then you put programmer on one side, poet on the other side. Then he'd put the grade he considered to be acceptable in the middle. And he'd say, if your grade's on this side of that, you're a programmer. If your grade's on that side of that, you go be a poet because you're not going to be a programmer. They were, yeah. Instructors weren't kind and friendly like we are now. Seriously, one of my first programming instructors actually had been a drill sergeant, and he actually wore his hat. I've had two drills. I've never been in the army. I'm not a veteran, but I've had two drill sergeants in my life. When I started competitive swimming, my first swim coach had been a drill sergeant. He wore the green cap, and he would march up and down the pool while we're swimming our laps, barking at us. McMillan, you're breathing wrong. McMillan, get your arms up higher. McMillan, synchronize your kick.
My grandma can swim better than
yeah. And then my second drill sergeant was one of my first programming instructors. He was my Fortran teacher. That was kind of funny. Anyway. But they would have, and there was no, can I redo this assignment? No, 0. You screwed up. And that was back when literally they would say, okay, look to, the freshman class, they walk in and say, okay, look to your left or right of you. One of you ain't going to be here at the end of the semester. Maybe 2 of you, if we're hard enough. Times have changed. The head. That's all you need. That's all you need because everything is being built dynamically and it lives dynamically until the program ends. We don't have a destructor, but we could probably throw one in. But that's one of the neat things about programming class versus programming real world. We're not worried about memory leaks. since our programs are so, whatever. All right, so the print literally, first if the head's empty, if the head's null, then we're not going to do anything, so we write out it, list is empty, stop. Otherwise, we simply traverse down the list. It's like I did in the example last week, checking to make sure that we're not at a null node. And we use a temp node to move us up and down, okay, which is standard. All right, so let's build a couple of nodes. I should have made a shorter member function name that inserted head. Oops, too many semicolons. So what does this list, what does this behavior remind you of?
Like you're saying, we have to insert a bunch of stuff manually?
No, just think about how we did this. Notice the nature of the data being input and how it's being stored. Not a vector, but what other, is there another data structure it reminds you of that we've talked about before? Well, have we talked about a last in, first out type of data structure? No, I think we haven't talked about stacks. Really? All right. So our next data structure, actually up on the list after linked list, is a stack. I thought we talked about it. I know. I thought we did it in computer science too, where we.
had a brief discussion about.
All right.
A little bit, but.
All right. Well, anyway, so a stack is what's called a last in, first out. So the most recent data put into a stack is push and pop. Y'all remember push and pop?
Yeah, we compared it to a
Or Pez dispenser, or the better one, but now it's so people don't understand it, cafeteria trays. No one goes to cafeterias anymore. I mean, that was like the big outing for me when I was a kid. Oh, we're going to go to Frankie's, or we're going to go to whatever. Now it's like, or Bonanza trays. I haven't been at Bonanza in so long. Are they even around anymore? That was now it's like DoorDash and that stuff. But yeah. So a cafeteria tray, so you have the trays in the cafeteria. When you wash one, then it goes on top. And when a customer comes in to get a tray, they take that same one off. So that's the last one in is the first one out. I know that people used to do this. Like if the top one was dirty, you'd lift up a few trays and try to find a clean one and pull out. But normally you can't do that. Like in a stack, you can't do that. No. We used to do that when we go to cafeterias all the time. Anyway, all right. But that's what inserting at the head is doing, right? Because one was the last piece of data in, and it's the first piece of data out. See, because I inserted backwards. Let's change that order, and then we'll see. Four is the last piece of data in, and it's the first piece of data out because it's stored at the top. So what we're doing is, and this might be a good exercise, is let's implement a stack with a I'll have to think about that. That's not how you do it. All right, so let me do a little drawing. All right, so this is your template, sort of, for linked lists. And now let's talk about what I want you to do. We're not classing with you. See if I can draw. So, your first modification.
Does that get recorded in the screen recorder?
I don't know. I bet it doesn't.
Your screen.
I bet it doesn't.
He's like 10 minutes deep into this like visual graphic. He's explaining, and he's like, "So you see? Don't you see?"
I didn't even think about that. Because that's just coming up there.
Yeah.
What's
You're just
recording?
projecting
It's
off
recording off my, So damn, I'm gonna have to come up with this with the whiteboard out for my computer.
Oh, and you just
Yeah, do it from there. All right, so for people who are watching, I will provide these. I'll have to come up with my own diagrams. All right. So this funked up for you three. Sorry, everybody else. I'll figure out a way. I know what to do. What you probably want more often, more regular than that, is insert after head. So that's the first modification you're going to make. That's why I want you to draw out how inserted head's working, so you can see how what it does. You have a question, or
Yes.
Are you stretching?
No, I have a question.
All right.
With linked lists, is it impossible to like say, hey, I want to take out element nodes 6 through 9?
No, you can do a range. That might be an end of semester project. It'd be harder. I don't know, I want to take the time now. And I'm thinking about, for a final, just having one big project that involves several different data structures and some changes to that. Like, no, not a game. Just for the linked list class that you built way back in September, now implement removing a range. That way, I'll give it to you like in 1st of November. And then you can work on it all the way until speaking of that, there's maybe think of something. There's not going to be a final on the final thing in this class. That's right now. So we're going to have a final. The final will be due last day of class. It will be a project.
Oh.
That's kind of what made me think of that too. All right. So your first homework exercise is going to be to modify inserts so that the inserts come after the heading. So you have a head node, but everything is inserted after the head node. So that's number one. I need to make a note of that. That's the first thing, after head. Number two, what if I want to insert 2.5 into this? Okay. Again, we've talked about this. What you have to do is, and I'm not going to get all the erasing stuff. I'm just going to scratch it. So you create a new node. Then you say, okay, the new node's next link is going to point to what. So this is called insert after. So if I called insert after 2, then what you're going to do is, first of all, you got to find 2. So you're going to need a member function called find. That would be an excellent private member function because it's not going to be something you're going to use as part of the interface. So you got to find 2. Then you're going to say, okay, now 2's next link. The new node is going to copy 2's next link so that it's doing that. And then you found 2. Now it points to 2.5. So that's called insert after. So that's the second thing. Well, actually the third thing. So insert after head, find private member function, insert after, and then the last one will be remove after for now. So now if I want to remove 3, no, if I want to remove, let's say I want to remove 2. Okay. Oh, how do I want that to work? Not remove after, just plain old remove. All right. So if I say remove 2, you got to find 2, and then you got to say, okay, the node that pointed to 2 now has to point to 2.5, and then you need to remove 2 from memory. This is delete. So remove 2, you got to find it, because if it's not there, then of course what? That's not an error, but you might say, big enough now, whatever. And then you got to change the links. Okay. So now 2's link. 2 now has to point to 2.5. No, I'm sorry. 1 has to point to 2.5, and then 2.5 copies 2's next link, so that it now points to 3, and so that 2 is now removed from the list. But remember, don't lose track of it or lose sight of the fact that this is so much better than if we have one big long contiguous array and we have to do a bunch of swapping, a bunch of shifting back and forth to make room. There's usually about 3 steps involved. 3 to 4 steps involved in every insert or remove. But that also is better than maybe 10,000 shift lefts or 10,000 shift rights, depending on if you're adding data or removing data. And that's assuming that you have enough space in the array to do it. If it's not a dynamic array, if it is a dynamic array, then you can copy and all that. But that takes a lot of steps too. All right. So this again, linked lists are great when there's lots of insertions and deletions. They're not great, But on the other hand, if we have 10,000 numbers and you've got to find a particular number and they're not in sorted order, then you've got to just go link, the link, the link, the link, the link, the link, the link to find it. So linked lists aren't great for random access finds. Fine. Sorry. I'm thinking in terms of an actual. No. Well, like a find. I mean, to find one element in a linked list is a lot more costly than in an array.
There's no way around that.
Not in a linked list. Okay, so there's 4 member functions to write: insert after head, find, which is a private member function to find a data element in the linked list, insert after, and remove. And that means a specific remove just takes the data element you want to remove. All right, now the other type of linked list, which we're not going to implement in class now, but we'll make another good end of semester project, is what's called a doubly linked list. Let me erase. It's only 3 that you can see anyway. It's getting more, except for the fact that it's not recording right. go back. No, but no one who's watching these videos has complained.
They might say it on there. I don't remember.
I should not. This is not. It's recording my
And
computer
it's projecting
screen.
it onto there.
And and this is happens this weekend. All right. So the other thing that you need to learn, you need to know about is what's called a doubling link. So the way a doubling link list works is, and I'm just writing null, but I mean null pointer. It's too bad this didn't record. All right. In a doubling linked list, you have forward links and backward links. So that if I'm here and I want to get to 1, if I'm in a singly linked list, the only way I can do that is to go all the way back to the head and start back in the forward direction. But now if I want to go backwards, I can just say, okay, follow my previous link or back. You know, I call it back. It's called the back link. And I can just follow the back links and go backwards. Okay. The price for that is you have to have another field, another member variable for the back. But the good thing is now you're not stuck restarting every time. So that would make another good end of semester project to implement a doubly linked list, and then some member functions for moving forward or moving backwards, and finding previous, and blah 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 blah, all that stuff. It also makes insertions and deletions a little bit harder because now you got to update 2 links. Now you got to update 2 links instead of just 1.
So technically, can you add as many links as you wanted?
Well, what would you need another link for?
Or what if it went? You don't.
We're not going into another dimension. Okay. 3D
link.
3D link list. Okay. If you want to do that, fine. That gives me a headache right now to think about it. I'm a strictly 1 to 2D man. I can go linear and I can go 1 level deep. But that's it. So after 2 dimensions, I'm like.
Then you sort it into a tree.
We're gonna talk about trees. That's not the same thing. All right, so I think we're done. But let me make sure. Let me think for a second. So seriously, if you just want to start coding, that's fine. But what I would do is I would draw this out, the insert at head, with a couple of insert a couple of nodes just to see how it works so that you understand how to implement inserting after. I'll post this. We have 30 minutes now. We're probably going to leave linked list after this. And come back to them next week when we go over the homework. But I think we'll on Wednesday we'll start talking about stacks. We're a little bit behind. I'm always behind, but we got to get through stacks and queues, and maybe even decks. Remember you talked about decks?
Yes, DQs.
Sorry, that's Dairy Queen. When you say DQ, I think of Dairy Queen. The DQs. Yeah. Again, it's perfectly understandable because my wife and I thought that Nuki was New Quay forever until our friend from England laughed hysterically at her pronunciation and said, "Are you crazy?" In fact, Timothy, that person is another nurse at Children's you might have run into, Denise Pearson. Is that name? English, very proper English. There's several English nurses at Children's, but And I don't know that because Denise was working on the resource team, the same as my wife, so that's possible that she could have floated through your area before. Anyway, she was the one that laughed hysterically when we said nuclei. And sorry, that's pronounced nuclei. And DQ is pronounced deck. But not like a deck of cards. Okay. Well, no, it is like a deck of cards. You know, because a deck of cards, you can deal from the top or the bottom. Now, of course, you get in trouble if you're dealing from the bottom, you know, and someone catches you, supposedly. I don't know that much about gambling and how, but a deck is, all right, so let's talk for a minute, since we're 30 minutes early. So stacks. Stacks and queues are two of the most common, not common, but the most, are some of the oldest data structures that have been around. So the stack, again, is a last in, first out data structure. So there's lots of things. I thought we talked about this a lot. Still drawing. So if I push 1, 2, 3, 4 onto the stack, so folks who are watching this recording, I will provide a different view for this. So the only access you have to a stack is through the top. So you can only access one piece of data at a time. Okay. So and there's only really two primary methods. Member functions. Push to push new data onto the stack, and pop to remove whatever's elements at the top. That's all you can do. Okay. And then when you pop, then the top then becomes the next element.
So if you want to clear all the data, you can clear it individually?
No, theoretically, yes, but practically, no. Almost every implementation includes a clear and an empty. Well, theoretically, no. You should have to pop the stack until you're out. Okay. But practically, that would be crazy. So yeah, there's a clear member function. There's an empty to check because trying to pop an empty stack is an error. You don't want to do that. So you have an empty to check to see that it's empty. Anyway, so there's lots of cool implementation things that are based on stacks. Function calls in a compiler are stack oriented.
Okay. Now we're getting into the cool stuff. That kind of goes into OSDEV, right?
Mm-hmm. Operating systems, lots of those are queues more than stacks. But anyway, well, there's several different things but there's lots of cool implementations you can do. Like you can build a decimal to binary number converter using stack. You can check to see if words are palindromes. Palindrome is
a kayak.
Yeah, kayak. There you go, Bob. A man, a plan, a canal, Panama.
What?
A man, a plan, a canal, Panama. That's it.
Say slower.
A man, a plan, a canal, Panama.
A plan?
A man, a plan, a canal, Panama. If you put all those letters into one string, it's a palindrome.
Oh, okay. But without, I think you said plan.
No, plan. Make a plan.
The whole sentence.
The whole sentence, if you scrunch out, you take all the white space out, is a palindrome. Race car.
Yeah.
Stacks can be used to do that. You can use a stack to make sure that parentheses are balanced in the expression. Push a left parenthesis onto the stack. Every time you get a right parenthesis, pop that left parenthesis off. And then if the stack is done and you still have a left parenthesis on there, that means you have unbalanced parentheses because you have a left stack left on. It needs to be in the pin. Go back and forth. Yeah, just push a button and it erases. Push the button back, toggle it, and then it's a pin again. There's an opportunity for you.
Parentheses.
I just did parentheses. Oh, I know. So, infix to postfix. All right. With infix, you have to use parentheses if you want to change the order. But if you do it postfix, you could say 1, 2 plus 3 times. And that'll get you the same thing as putting the parentheses. So you can, and like a calculator will store if you're writing an expression in a calculator, it'll store it in postfix. They used to call that reverse Polish notation. I think they cut that out. It's kind of non-woke. Seriously, RPN, that's how I learned it. Now we just say postfix. But seriously, that's another thing. Because then with postfix, you don't need parentheses at all. And those would be great little end of semester projects to implement an infix to postfix converter using the stack that you created. So we'll look at the stack class that's part of the STL, and then we'll implement our own. That's kind of thing. All right. So queues. Let's do a little more erasing. I guess this is fast. So a queue, Q-U-E-U-E, is used to simulate a line, like a grocery store line. Line. So
Like a sequential order, you're saying. That's the same.
yeah. Ooh. So in a queue, you have a front,
Like order of operations.
and a back, right? So all data goes in through the back, and all data comes out the front. So queues are used a whole lot in simulation. So like when Kroger is trying to decide how many self-service checkout stands are going to be versus full service, they might use a queue to simulate. Okay, if there's 4 people in line there, and there's 3 people there. How many, or how many checkers do we need based on how things are set? So queues are used a lot for simulations. And again, you can't cut, you can't move from the back to the front without going through all the data that's already there. And so those are, so like print jobs to the operating system. If we all sat here and sent jobs to that printer, then whoever did it first would be the first one in, the second one in, the third one in. So those are stored as queues. So queues are easier to understand than stacks, because everyone's had to get in line for something, or online, as they say. So simulations are hard because they're very involved, and you have to know things like you have to figure out like how to measure time and like
You're having to cycle at different intervals.
yeah, simulations are hard. So we're not going to do that. We'll come up with some easier examples for queues that aren't quite so involved. Simulation. Now, if you're like an industrial engineering major, that's a whole semester.
Are you going to have us learn any specific libraries outside what you've already taught us?
Other than the STL, no. What else? What other library would we use?
Well,
You obviously have one in mind.
Yeah, I did. I would like to learn how to operate one that allows us to like use a terminal as like this pop-up window and have something like graphical. CSTD.
Oh God. So you want a graphics library?
Yeah, I
Wow. So that's graphics library.
I tried in cursive and I figured out that I couldn't use it because the operating system that I was using for Mac and I was using
Yeah.
it for.
Yeah. That's
If you want a GUI, a graphic user interface,
With C++.
using a game, because you can visually design it instead of having to
what you telling me to use?
a game engine.
Oh.
In his case, since you want C++, I would use Unreal. Because Unreal
or use a language that has a visual interface built into it, like Visual Basic, or even C#. You might be easier to use for that than C++. So years ago, I used to try to teach object-oriented programming using a graphics library. It took us way too long to get everyone to get the graphics library. It was harder than trying to get the assembly language to work. And so think about how hard some people, especially for my tutors here, how hard it's been to get some people to get that's a breeze compared to trying to get one of the C++ graphics libraries. At least back then, I haven't tried one yet because it was like once.
Oh, it's called SDL library.
I've never heard of it. They're I haven't looked again. It's been years. It's been 11 years maybe since I looked at it.
I saw someone using it, I think, on YouTube as a chess game.
Yeah, sure. Like if when I had my classes do Wordle, it would have been really cool if they could have built Wordle like it is on the real application. Man, trying to get the graphics. But it might be easier now. I haven't looked at years. If it is, then I can go back to using Strip's book on Introductory C++.
It's called Simple Direct Media Library, and it's cross-platform, so it supports both Linux and Windows.
Yeah, but I mean that's good. I wish I could. I wish we could have to use it. That would be like when I used to require everyone to use a command line compiler. Eventually the complaints to my dean got to be so bad that I said, all right, well, we're not learning a system that we can use on the job.
I think
I don't care about that.
It forces you to learn everything else inside it because
one of the best things I ever saw on a chat room in programming. Some guy was saying, "What's the best code edit? What's the best IDE to use for C++?" And some guy said, "First, implement your own. Then, when you can implement your own, you can use anyone you want." Because build one. Now that's hard. That would be really hard. But the point is that, and I think all programmers need to know how to use the command line. Because at some point you're going to have to. I love using the command line. I broke out we were doing something in Computer Science 1 last week, and I was like, I wonder if JavaScript has it. And then I thought, oh, I've got a JavaScript shell on that workstation there. And so I just thought, it's just the DOS talk thing. I thought I was doing some sort of magic,
I saw this meme, and it was a guy making like a quadruple step up a set of stairs, like he's skipping 3, and then first right from the fourth one. And each stair, like the top one said hacking, the next one below that said Linux, like administration or Linux, and then it was like basic computer classes or something.
Just get everything right.
And it was trying to convey this is how people try to start, I guess, learning hacking or something. Yeah. They try to skip everything else and go straight to hacking before they know we did this stuff.
Yeah, you can't do that. It's like you can't sit down. And this doesn't happen so much anymore, but it used to be I'd have students come into Computer Science 1, and by the time we got the if statements, they were ready to give up. And they said, well, I said, why? They said, well, I want to start designing games, and it's taken too long to learn to use that. I'm like, oh my God. You don't even know what you still have to learn before you're going to be designing your own computer game.
And especially in today's age, you have game engines. Learning the language is a core of it. Like when I make games with my buddy, one of us takes maybe a week or 2 to implement all the basic mechanics and programming. The rest of it is learning the game engine, not even programming.
So yeah, when I hear that, I'm like, okay, probably.
Well, that's a self-discipline, an expectation, like unrealistic expectations. Is what I would call that.
All right, So the next thing we're going to talk about after, so I'll probably on Wednesday we'll look at stacks, and then we're going to build our own stack using I don't know, using an array or maybe even a vector. I'm not sure how difficult I want to make it. But you see where I thought this linked list where you insert at the head, it's exactly what a stack does. But it may not be. The problem is, see, I didn't think about it until I was going through that. I'm like, oh, that might be a good way to implement a stack. I may play with that between now and Wednesday if I have time and see if that's something we might want to do. Or it might be a nice little exercise or homework or project. All right, I think I'm done. Be looking, I'll put this assignment, these 4 things to do with this code, I'll put that in Blackboard here in about another 30 minutes or so. That's all.
I got PS code working on my full reinstall. I don't know what I did wrong, but I just wiped everything.